it's time to train our model. Here is what we're going to be doing in session 4. We are going to be taking all of the outputs that we generated in the previous session during the processing step, and we're going to be training a machine learning model with those outputs. So let me show you. Let me go back here to our website, session 4, and let me show you like a high-level diagram of what's going to happen today. We have the pre-processing step that we built in the previous session, and as a reminder, we created a bunch of outputs out of that session, including the train and a validation set. And we are going to use that train and that validation set as part of this training step. The training step will create a model, and we will output that model that we will later use to evaluate that model in a future session. So this is what we're building today. Going back to our overall diagram, let me just make it a little bit bigger. We already built this processing job. So we got the data from the bucket. We ran the processing job. That processing job outputted the dataset splits and saved those splits in a bucket in S3. Now we're going to run the training job, which is this one here. And this training job, notice that it's using the train and the validation sets from the dataset splits bucket, from where we saved those splits. It's going to use those to create a model. And in the future sessions, we will see what we do with that model. But our goal today is just to create that model. So let's look at the code. This session should be shorter because the code is going to be simpler. So how do we start? We're going to do exactly the same thing that we did before. We need to create the script that SageMaker will use to train our model. Now, here is the thing. SageMaker offers a bunch of out-of-the-box algorithms that you can use to train your models. So if you don't want to deal with code, you can use a pre-created algorithm to train your model. You can use an XGBoost algorithm. You can use a linear regression algorithm. SageMaker has a whole library of algorithms to do that, where you specify these are my columns, and SageMaker will run the algorithm and will create a model for you. We're not doing that here. I want to create my own model. Therefore, I'm going to be specifying a script with all of the code that I need to build that model. So let's start by creating that script, which is the same thing we did when we were working on the pre-processing job. So first, I'm going to create a folder to the same thing that I did before. This folder is going to be called training. And inside training, I'm going to be saving my script. And I'm adding that folder to the system path so I can later import this script and test it. So my unit tests can actually test the functionality within this script. Here is my script, and we're going to go line by line so I can explain what I'm doing here. Let's look at the entry point of my script. By the way, I'm going to show the line numbers so it's easier. You can show and hide line numbers on a notebook pressing the letter L, and if you type Shift L, is going to enable or disable line numbers for the entire, see? Enable, disable for the entire notebook. So now I want them enabled. So let me go to my entry point. This is the entry point of the script. This is where the script is going to start running when I execute this. It's going to start running right here. Now, here is the thing. First thing I'm doing as part of this script, I'm parsing out the arguments. SageMaker is going to call this script from the command line. When it runs inside a Docker container, it's going to call this script, and it's going to pass arguments to this script. And you guys are going to see in a minute how you pass different values, how you pass different arguments. For now, I want my script to receive the number of epochs or iterations that I want to run my model, and the batch size. How many samples am I going to use during one of those epochs to train my model? I'm going to be building a neural network. You do not need a neural network to solve this problem. I want to be clear. This problem, you're probably better off just using a linear model, maybe a tree-based model like XGBoost or CatBoost. I want to build a neural network just because I'm happy that way. That is why I'm using a neural network here. Neural networks, I need to specify a batch size to run gradient descent. That's going to be the optimizer that I'm going to use for this neural network. So I want to control the batch size from outside the script so I can pass different values. And that is what I'm doing here. I'm passing that as an argument. I'm using the argument parser library, Python library, to read those arguments. So notice how I read the argument epochs, is the type integer, and if it's not provided, I'm just gonna assume the value is 50. Okay, that's the default value. And for batch size, if it's not provided, I'm going to assume the default value is 32. Nothing fancy. Here, I'm gonna be loading the API key and the project name for Comet. As a reminder, in the first session of the program, we configured a Comet account. It's a free account that we're going to be using to track the training jobs. All of these experiments, we want to keep track of them. That is very, very important. So from within the script, I'm loading the API key and the project name, where I'm going to be tracking all of the information. I'm loading them from environment variables. So I need to remember when I configure my training job later on, I need to pass these two environment variables to my script so I can actually read them from here. So then I'm going to create an experiment. If the API key and the project name are provided, I'm going to create a Comet experiment. And you're going to see how easy it is to use Comet. You just create an experiment and that's it. That is all that you need. And just by doing that, Comet is going to take care of tracking a bunch of data for you. So I'm going to create my experiment. I'm passing the name of the project. So all of that information is tracked under the same project name. I'm going to be passing the API key. I'm going to be specifying I want automatic metric logging. Just please do this because I don't want to do it manually. I want Comet to take care of that. Automatic parameter logging, yes. Log code, true. So basically the code that's running this is going to get logged together with my experiment. That is crucial. You want your experiments to reflect the status of everything you ran at that time. So I can go back in time a year later and say, what was the code that I had that day when I got these results? And Comet is going to show me the source code. And it's going to do that automatically because it's logging the source code here. So I'm going to create this experiment. Then I'm going to look at this, what I'm doing here. I'm reading from the environment variables. SageMaker will automatically create an environment variable that's called SM training env. And notice this SM, that means SageMaker. Anything that SageMaker creates here is just going to pass here with the prefix SM. And within this training environment variable is a JSON, and there is a job name there. There's an attribute job name. That is the training job name that SageMaker will automatically assign to this training job. So I'm going to grab that. I can name my experiment in Comet using the same name. So I know exactly which experiment in Comet matches which training job. You don't have to do this, but if you do this, it's going to be much better. It's going to be easier to track that experiment. Here we go. If I get the job name, if I found the job name, I'm going to set the name of the experiment to that job name. If these two lines don't execute, you're going to get an experiment, but Comet is going to assign a random name to it, and then it's going to be harder to know which one is which. Cool, awesome. So after doing this, I already set up my experiment. I'm going to call the train function. Let's see the data that we're passing. First, I'm going to pass the model directory. This is a directory that SageMaker tells me anything that you save inside that directory, I'm going to compress, I'm going to assume it's a model, and I'm going to upload automatically to S3. SageMaker tells me that and gives me an environment variable that's called smModelDir pointing to that location. So I need that so I can save my model assets to that folder. Then SageMaker gives me 3 channels: train, validation, and pipeline. Those 3 channels, those are the inputs to my training job. And I'm going to talk more about the channels later when I configure them. For now, assume that there are going to be 3 environment variables pointing to the location where the training data is, the validation data, and the pipeline data. Remember, the pipeline is the transformation pipeline that we created during the pre-processing job. SageMaker is going to give me access to all of those, to locations, to all of those. And later, again, I'm going to explain in more details what the channels are. Then I'm going to pass the experiment. And then finally, I'm going to pass the number of epochs and the batch size that I got from the arguments. So that's just my call to the train function. Let's now look at the train function here. Train function is going to be really, really simple. So here's the train function. So first of all, I'm starting by printing out the version of Keras that I'm using. And this will become, you're going to understand why I'm doing this during the next session. Just as a sort of like a preview, I'm going to be using Keras to build my model. And in this case, TensorFlow is going to be the backend that's going to be used to run my model. Keras is sort of like the front end. But in the next version, we're going to be using the new Keras version with JAX as the backend. And you can change that to PyTorch if you wanted to. So this is going to be critical because we want to be using Keras 3 for that. But I'm not going to get ahead of myself. I'm just printing out the version of Keras that I'm using during this session. Then I'm going to be reading the train data from the location that I got, right? So remember, I'm passing the train path here. I'm going to be reading that train data using pandas. Read CSV is going to read that data in memory. I'm going to grab the column, the final column, this -1 here. It's basically starting from the end, the final column, grabbing the first column from the last. So that is my target column. If you remember in the previous session, when we saved the process data, we put it together. We put together all of the columns and we concatenated that with the target column. And we saved that. So now I'm doing the inverse process. I'm loading the data in memory and I'm grabbing the final column and splitting that final column. So I have basically one matrix with all of my columns. That's what we want to use to train our model. And one vector containing the target column, right? So you can see how I grab that vector, that target column. I'm storing it in the yTrain variable. And then I'm dropping that final column from the xtrain. So I'm going to have features and target separate. And I'm going to repeat the same thing with the validation data, okay? Exactly the same thing. Now it's time to build our model. So let's see how we build our model. Again, I'm using Keras. So everything that you see here is Keras. So I'm going to be creating a sequential model. Sequential meaning there's going to be one layer after another. The input of my model is going to be of the same shape. It's going to have the same number of inputs as the number of parameters or columns I have on the training data. I think it's like 6 columns that I'm going to be using for training these 6 or 7. I don't remember how many, but that is the number of inputs we are going to have. That shape in 1, that gives me shape in 0. That will give me the number of rows. Shape in 1 is the second dimension, the second axis. That will give me the number of columns. So that's what I'm saying here. I'm creating an input layer with the same number of input neurons that I have features. Then I'm going to have a dense layer. This is a fully connected network with 10 neurons. That's my first layer after the input. And it's going to be using a ReLU activation function. Then a dense layer with 8 neurons, and finally a dense layer with 3 values and an activation function of softmax. Let me try to explain this really quick. This should be obvious for anyone that has built neural networks before, but notice that the output layer of this network, I wanted to have 3 neurons because each one of them corresponds to a class that I want to predict. The penguins data set, the target is the species, and we have 3 potential values. So we need 3 neurons on the final layer. And each one of those values is going to be a value that the bigger it is, the higher the probability that that sample belongs to that particular class. The softmax here is an activation function. It's a function that's going to get applied to that layer and it's going to force the sum of those values to be 1. So here's what's going to happen. I'm going to create a new cell here just to give you an example. If that final layer is 0.2, 0.7, 0.1, if these are the final values that I get after applying the softmax function, notice that these values add up to 1, you can conclude that the correct class for this penguin is this one here, the one corresponding to 0.7, because that's the highest value. So that's how we read that final layer. And the softmax will make these 3 values, will squeeze proportionally these 3 values so they add up to 1. All right, so let's go back to our network. So we defined, where is our network? I lost our network. Okay, so we defined our model. Now we're gonna compile that model. And when you compile in Keras, you basically pass the optimizer, the loss function that you want to be using, and you specify which metrics you want to track. So the optimizer that we're gonna be using is stochastic gradient descent. That's the optimizer that we're gonna be using with a learning rate of 0.01. So it's small learning rate. The loss that we're gonna be using is a sparse categorical cross entropy loss. And the metrics that we're gonna be using, we're gonna be tracking is the accuracy of our model. So we want to keep track of how accurate is our model. As we start solving the problem, as we start training the model, I want to keep track of that accuracy. How is that accuracy changing? Now, I'm not gonna get into too much of why we're using this particular loss function. It has to do with the format of the target value. The target here is just an ordinal value 0, 1, 2. That's why we want to use a sparse categorical cross entropy here. This is a multi-class classification. That's where the cross entropy comes from. So those details are more like, they belong more like in a machine learning tutorial, but hopefully this makes sense. This is our model, is compiled, is ready to go. I'm gonna call the fit function. When I call fit, I'm gonna start training the model. So we're gonna fit this model, and I'm gonna pass the features. I'm gonna pass the target values. So when we train a model, we want to tell the model, here are all of the samples, and here are the correct answers for those samples. So as you start learning, you test your knowledge against these particular samples here. Then we're gonna pass the validation data. The validation data, the model is going to use to pretty much, when it finishes training one round, it's gonna apply the model to all of the validation data and compute what the accuracy is. So we can have, as the model trains, as more epochs go by, we can see how that validation accuracy is changing. We can see how good the model is getting. We're gonna specify how many epochs we want to run. Remember, by default, we have 50. What is the batch size that we are going to run? By default, we have 32. And the verbose indicates what type of logging we want to output. So when this model runs, there's gonna be some logging. I'm using level 2 verbose. You can use level 1 or level 0 to just kill the logs. After this line, our model is gonna be trained. So I'm going to take this model, and just for logging purposes, I want to print out what the final accuracy is. So this is what I'm doing. I'm grabbing the model and I'm calling predict on the whole validation data one more time, or like the sun says, one last time. I'm gonna predict every single row from my validation data, and I'm computing the argmax. And remember, what we get out of a model are 3 values, because we have 3 neurons in the final layer. The argmax, let me show you here. Oops, sorry, I clicked where I shouldn't have. Let me create a new cell here. Remember that, let's say that we have this output, and the output is 0.2, 0.7, and 0.1. If we apply argmax to this, if we apply argmax to this vector, what we are going to get, well, first, before applying argmax, let's apply max. If we do this, this is obvious. We should get 0.7 back, right? So if we run this, we should get 0.7 back, because this is the maximum value out of this. But I don't care about that value. What I care about is the class, like which position does that 0.7 represent. That is what argmax is going to give me. So if I run this, I should get 1, because 0.7 is index 1. So if I run this, I get 1, which is awesome. Now let's say 0.7 was here, or let's say this is 0.6, and this is 0.2, and this is 0.2. Now I should get 0, because the largest value is the first value of that array. So that's what the argmax is giving me. So in this line, where I run the predict, I predict all of the data, and I call argmax. What I'm going to get here is an array with the final answer for every single sample from the validation set. And by final answer, I mean 0, 1, or 2. So what is the final answer predicted by my model? After doing that, I'm going to use an accuracy score function. This is a scikit-learn function that is going to compare the Y validation with the predictions. The ground truth, which is the Y validation, those are the real answers with the predicted answers. And it's going to compute what the accuracy of my model is. So I'm going to get this validation accuracy, and I'm going to print it out. I just want that just for logging purposes. To see when the model finishes training, I want to just look at that line and say, your model is 80% accurate, whatever the model says. After that, I need to save my model. Now, notice there is some versioning issue here where I'm saving the model, but I'm doing it differently depending on the version of Keras that I'm using. So notice that I'm saying if I'm using Keras before version 3, I need to save the model like this. I just need to specify a directory where to save the model. But if I'm using Keras 3 or above, I need to specify a file with an extension .keras. That is a change in Keras, and because I'm going to be running this same script with 2 versions of Keras, and that will become obvious in the next session why I'm doing that, I want to specify here, hey, depending on the version, save the model this way or that way. One more thing about saving. This weird 001. It turns out that we are going to be running this model later when we deploy it. We're going to be executing this model, running inference using TensorFlow serving. So TensorFlow serving will load this model in memory and will help us just serve the predictions of this model. TensorFlow serving requires us to provide every version of the model inside a directory that represents the version number. So if I have 2 different models, I need to deploy them inside TensorFlow serving each of those models within a numerical directory that indicates the version number. And TensorFlow serving uses that number to determine which version is the latest version and which version it should use when deploying the model. So we can have the same exact model, but multiple versions, and TensorFlow will be able to load the latest version and maybe go back to the previous version if there is a problem there. So that's why when creating this model, I'm just hard coding a numerical folder here. So I'm saving this model to the path that SageMaker is telling me, save your model inside this path. I'm creating a folder, has to be numerical, and then I'm going to be saving my model inside. So here, after I compute the model file path, I just go and save the model. I call the save function of my model, and that is going to save my model into that path. Again, the way it's going to look like, it depends on the version of Keras. After I do that, here is what I'm going to do. After I save my model, I'm going to do something that later on is going to become critical for me. I cannot serve this model without transforming the data first. This model expects data that was transformed before. It cannot use raw data, right? It cannot use the island column as a text field. It requires that island column to be formatted as a one-hot encoded value. Therefore, there is no point for me to save the model alone. Instead, I'm going to save within the same package, within the same, as like at the model assets, I'm going to put together the TensorFlow model, the Keras model that we just created, with the transformation pipelines that we will need to use whenever we want to serve that model later on. That's why I'm grabbing the input to this step, which is the transformation pipeline, which is one of the outputs of the previous step. and I'm extracting that model.targc. I'm extracting those files, put them inside the same folder as I'm saving the model, and letting SageMaker deal with that. So I'm basically putting all of the files inside a folder, inside the output folder, and telling SageMaker, that's my model. So SageMaker is going to package that up, move it around, and we will always have everything we need, which is three things: the TensorFlow model, the transformation pipeline to change the fields, and the target pipeline to transform the target values. We need all of that. Awesome. So this is what you get here. I'm extracting everything inside the model directory. So what you're going to get is 001, and then the target.joblib, and then the features.joblib, which are the two files that are going to come here. And then that's the output here. Then I'm doing one more thing, which is I told you already that Comet is going to track a bunch of stuff automatically, but I also want to track extra things that I want just to keep track of. So I'm saying, hey, if I have a Comet experiment, if that is enabled, please log these two parameters, these two specific parameters. I want to log them because those were the parameters that I got passed. Please log them, those two parameters. Log a dataset hash, so I can later go back and reference the same exact data that I used to train my model, and log a confusion matrix. So compute a confusion matrix for the validation data. See how I'm passing here the Y validation and the predictions? So this is gonna create a confusion matrix. I'm just gonna show you in a few minutes what that looks like. It's going to create that confusion matrix, and it's going to log that confusion matrix. It's going to look beautiful. And finally, log the model, log the output of this process. And the reason I'm doing that is because in Comet, you can also grab a model and register that model in Comet. Comet has a model registry, so you can just go directly there and register that model. We're going to register the model in a few sessions. We're going to register the model in SageMaker, but you can also register it in Comet. That's my script. Again, general overview. I load the data, the train data. I load the validation data. I define my model. I train my model. I save the output to the hard drive. I also save the pipelines, the transformation pipelines that come from the previous job. So they get compressed together with the model. And I log a few parameters with Comet. That's it. That's my script. Let's keep going on and see what happens after this. Cool. Here, this cell is just unit tests. So we are going to unit test that script before running the script. Really important to do that. So I have a few unit tests here, a couple of them. You can see when I execute these test sets or these tests, I configure them with only one epoch, so the tests run faster. I don't want to just run all 50 epochs. So I configure them with a single epoch, and you can see how here I get the log of that epoch, right? And here I get the log of that epoch as well. So it's just pretty quick. You can see the validation accuracy is only 37%. Well, obviously, I'm just running it with one epoch. It's not going to be better than that. So yeah, it's just to show you that those two tests work. Feel free to add more tests. Feel free to take a look at the script and decide what else can we test just to ensure we do not introduce any mistakes later on. Now it's time to set up the training step. And this picture that you're about to see should look pretty similar to the picture that we saw during the processing job. And it looks pretty similar because it's almost the same thing. There's certain things that change, but they are almost the same thing. Let me go back here so I can show you the picture, make it big. Let's go to the training step, click on the picture. All right, so as a reminder, this arrow here is going in the wrong direction, and I apologize about that. I'm gonna fix it. By the time you see this, you have the code in your hands, this is gonna be fixed. But here in the video, the arrow should be pointing in the other direction. So SageMaker will copy the inputs of our training step into the instance that is going to run behind the scenes. It's going to deploy a training container that we have to decide which training container we want to use. Then SageMaker is going to copy all of those inputs from S3 into the input directory. It's going to run our script inside this training container, and it's going to grab the output directory, read this. SageMaker will compress and upload the model.tar.gc file to S3. It's going to grab the contents of the output directory, and it's going to compress that output directory into a model.tar.gc file, and it's going to upload that to S3. This is different from the processing job. The processing job uploads the outputs directly to S3. The training job does not. The training job creates a single model.tar.gc file. It automatically compresses and uploads that to S3. Just like in a processing job, you could also specify multiple instances. If you want to do distributed training, we talk about distributed training during our live sessions. If you wanted to do distributed training, you could also do that. In our case, we're just gonna do one instance here, okay? All right, so let's go back to the code. Now it's time to set up the training job. But before we set up the training job, our container, it's going to be using Comet, and Comet obviously is not a default library. So the container, we need to provide access to the container that SageMaker is going to use to run our training script. We need to give it access to Comet. The way we can do that is just by creating a requirements.txt file. So I'm gonna create that file in the same folder where my training job lives. So if we go to code and we go inside training, you're gonna see that we have the training script. This is our training script. And we have a requirements.txt file. And in that requirement file, we're gonna specify the library that we want our container to run. Awesome. In this case, it's just Comet. So it runs Comet, it has access to Comet. Reminder, previous session, when we were creating a processing job, we had to specify a processor. And the processor was our way, our gateway to tell SageMaker which image to use, which Docker image to use, which version of that Docker image to use to deploy on that processing job. When you're working on a training job, the equivalent of a processor is an estimator. That's what we need right now. So I'm going to be creating an estimator that's called a TensorFlow estimator. If we go to the, I don't know if I have it open here. No, let's go SageMaker, SDK, estimator. Let's see. There we go. So if I open the SageMaker SDK, we're going to key training APIs. This is the estimator class. Let's go to frameworks. Let's go to TensorFlow. Within TensorFlow, we have a TensorFlow estimator, and the name of the class is called TensorFlow. This is not the TensorFlow that Google creates. This is an estimator, a SageMaker provided estimator. Internally, it's going to specify for us which Docker container to use. So we just need to tell this estimator the version of TensorFlow, and internally, SageMaker is going to pick a Docker container that runs TensorFlow inside, that's prepared to run TensorFlow inside. So that is what I'm going to be defining here. The TensorFlow estimator, a base job name. As a reminder, if we go back to SageMaker, there is a training tab here. Click on training jobs, and you're going to see here all of the training jobs that you're running. Notice this training job, it says training. That is this. So that is how you recognize a specific training job. The entry point, what is the name of the script that I'm going to be running? And the name of the script is script.py. And the source directory, where is that entry point script located? The source directory is code/training. So SageMaker is going to grab this training folder, that's the source there. It's going to zip it up, upload it to S3 automatically, and unzip it later, and then grab the script.py from inside and run that. After it executes automatically the requirements.txt file. So it's going to install anything inside the requirements.txt file. Look at this. There is a property called hyperparameters that I can use to pass arguments for my script. Remember, if I go back to the script really quick, in our script, we are expecting epochs and batch size. Those are two parameters that we are expecting. We can pass new parameters by specifying them under the hyperparameters attribute here. See, I'm running this TensorFlow estimator with 50 epochs and 32 batch size. If I specify potato here and I pass 10, I After doing this, I can just capture that parameter in my script because there's going to be a parameter called potato there. Cool. Awesome. So what else? Environment variables. Which environment variables I want to have available for this script when it's running inside my container. Remember, we're getting the Comet API key and the project name from the environment variables, so I'm going to pass them here. So they are available for my training container. Cool. This here, this is just horrible, but it's the way it works. So what happens is my script is going to be tracking all of the parameters using Comet. This is like advanced stuff. It's good stuff. But SageMaker also supports SageMaker Experiments, which is basically the same tracking system that Comet supports. But it's very, very rudimentary. I wanted to show you anyway how you use SageMaker Experiments if you want to stay within the SageMaker walled garden. And the order you do that is you need to provide SageMaker with the specification of how to capture every parameter from your script. And the way it does that is you need to provide regular expressions. So SageMaker grabs those values from the logs. It's horrible. I just got a headache just by explaining that to you. So look at this. I want SageMaker to track the loss of my model, but SageMaker doesn't know where to capture that loss. Like, how is it going to get that loss? SageMaker has no idea. So I need to give SageMaker a regular expression. So SageMaker parses the logs from my model and grabs the value of loss. Horrible. I'm sorry, but this is horrible. I need to pass the accuracy, or I want to track the accuracy, the validation loss, and the validation accuracy. And all those 4 parameters that I'm capturing here, they need to be part of the logs that I'm printing out as I train my model. If they're not there, they're not going to be captured because SageMaker doesn't know how to get them. You solve that problem with a library like Comet. You don't have to specify any of that. So anyway, I'm going to show you in both ways how the information is captured. So that's what I'm doing here. Then I need to specify which image I'm going to use. Here is the secret part. If I'm running locally on my computer, I'm on local mode, and I'm running on an Apple computer, not an Apple computer, but an Apple Silicon architecture, an ARM64 architecture, SageMaker does not give me a container that I can run here running TensorFlow. SageMaker doesn't have one, so it's going to fail. If you're running this on an Apple computer and you did not create a custom container image, it would fail. Luckily for us, as part of the setup process in session 1, we created an Apple-specific container that we're going to use here to test our model. Let's look at this config image. Let's look at the value that's in here. See, this config image says SageMaker TensorFlow Toolkit Local. That is the name of the container that we created in session 1. If you are running on a different architecture, if you have a Windows computer, a Linux computer, or even if you have an Apple computer running an Intel processor, your value is going to be different than this, okay? Because you are not going to be using a custom created container. This is only for people running on an M1, M2, M3 Silicon processor. So I'm going to specify that image. I'm going to specify the framework version. We're using 1.12 here for TensorFlow. I'm going to specify the Python version. We're using 3.10 in this case. All of those values come from the configuration. I'm going to specify the instance type. This is the type of computing power that I want to use. So this is going to be an ML M5 X large computer. Unfortunately, you cannot use the MLT3 medium to train your model. It doesn't fit in memory. So I'm sorry. You will need to have an ML M5 computer for training this model. Instance count. How many instances do we want to run within the cluster? Just a single instance. These two is I don't want a profiler. I don't want a hook for debugging purposes. I have assignments under this session that will help you understand how to use these two properties. So I'm not going to get into details right now. The session that we're going to be using, we talked about that before. This is either going to be a pipeline session or a local pipeline session if you're running this in local mode. And the role. What are the permissions that we want this step to run under? Cool, that's our estimator. What is the final thing that we need to do before creating the pipeline? We need to define the training step. Like we did before, we defined a processor and then the processing step. Now we need to define the estimator and the training step. Very simple. Here is our training step, and this time I'm creating a function because I'm gonna be reusing this function later. So I'm creating a function here so I don't have to repeat myself later. So this function is just gonna return a training step. This is the name of the step. When we look at the pipeline, you will see train model. That's the name of the step in the pipeline. Then I call estimator.fit. Remember, before it was processor.run, now it's estimator.fit. And because this is running as part of a pipeline, so it's using a pipeline session, nothing is gonna execute when you call fit. Nothing is gonna run. Everything will run when the pipeline runs. So estimator fit, and I need to pass inputs. I'm gonna explain every input right now, and that's it. Notice how I don't need to specify outputs on the training job. I do not need to specify outputs because SageMaker says there's only gonna be one output, and it's gonna be a model.tar.gc file that I will create by compressing everything within the folder, the output folder. So there are no outputs coming out of the training job. There's only one output. Sorry, there are no explicit outputs. There is only one implicit output, which is your model.tar.gc package. Okay, now let's see these inputs here. These inputs is what SageMaker calls channels. So you specify a bunch of channels. I don't know where that name comes from, but channels. So I'm going to specify a train channel, and I'm going to define it as a training input. Here is the key here. It's going to be an input that's going to be S3 data. Okay, see how I'm passing S3 data, and I'm pointing to the output of the previous step. Notice how I'm referencing here the pre-processing step, which is the previous step that we created. So when we put these two steps together, the training step will reference the pre-processing step. It would say, hey, just get the values from here. So I'm saying, hey, pre-processing step from the properties, yada, yada, from the output config, get the output that's called train. And if we go back to the processing step, let's do that. Let's go back to the processing step. Where did we define this step? Let me find the step here. It's after this. There we go. Notice that there is one output that's called train. So we're going to use this name to reference that output later as an input for the training step. Let's go back to the training step. It's right here. So we're referencing the train. And what is going to happen when we pass this input is that SageMaker will automatically create an environment variable for the script that's going to be called, I think it's channel dash, or, okay, so it's going to be called SM from SageMaker, channel underscore train. So if we pass here train 1, 2, 3, then the environment variable will be channel train 1, 2, 3. So I'm creating one for train, one for validation, same thing, just pointing to the previous one, and one for pipeline, same thing. The one for pipeline is pointing to my model, okay? So I should get, as part of my training script, 3 channels, 3 environment variables, SM channel train, SM channel validation, SM channel pipeline. Let's go back to the script really quick, just so we can see and make sure those are there. So if we go back to the script, look at this. These are where the paths are coming from. I get the train path from the environment variable called SM channel train, validation path from SM channel validation, and pipeline path from SM channel pipeline. That's how it works. Here's the cool thing. Here, I'm just pointing directly to these S3 locations. And what SageMaker is going to do, remember, is just to copy those files in my training container. There are multiple ways you can do this. You don't have to do a full copy. You might want to do a pipe. And when you do pipe, when you specify an input that is pipe, SageMaker will not copy the data. SageMaker will let you access the data as if it was there, but it's going to download the data upon request. So the idea with pipe is to make the process way faster. You don't have to wait for all of the data to get copied in your processor. That is especially helpful if you're training a model with a ton of data. You don't want to wait to copy a terabyte of data into a processing job. Neither you want to pay for 1 terabyte of hard drive just to copy the data. Piping will help with that. There are other different modes. There are assignments under this session that will sort of like point you in the right direction of how to do that. They're going to ask you to do that. Okay, so after defining the 3 inputs, I specify my cache. Remember, this is a function that we created, so I need to call the function. Train model step, that's the name of my variable. Create training step, and I pass the estimator, which is the one that we created right here. After this, the only thing left is just to define my new pipeline. This new pipeline is going to have 2 steps now. Not only 1, but 2 steps. So it's getting there. We're getting there. This is my pipeline. It's going to be the session 4 pipeline. And the session 4 pipeline is going to have now 2 steps, pre-processing step and train model step. 2 steps now, one connected to the other. Everything else is the same that we saw in the previous session. We have the dataset location, which is a parameter. We have the configuration, and we specify the session. That's it. And finally, we observed that pipeline. Here's one important thing. If I got to change the order of the steps, if I say train model step goes first and pre-processing step goes second in this list, nothing will happen. This is why, and by nothing will happen is nothing bad will happen. The order of the steps in a pipeline is not defined by the order of the variables in this array. The order of steps is automatically determined by SageMaker. Okay, so this order does not matter. It doesn't matter. You can put train first and pre-processing later, and they will still execute in the same order. Pre-processing, then train. The reason is because train depends on pre-processing. The input to train references the output of pre-processing. So you need to execute pre-processing first. Cool, awesome. So definition of session 4 is done. We are in local mode. Let's run this pipeline in local mode and see it working. So remember, to run the pipeline in local mode, go to the running the pipeline section, change the name of the pipeline that you want to start. In this case, it's going to be session 4. Execute this cell, and this is going to go and now execute my pipeline with 2 steps, not a single step. Before we saw just executing the training job. Now it's going to run before we saw it executing the pre-processing job. Now it's going to run the pre-processing job, and then it's going to run the training job. So it's running. There is a lot of information here that's coming out in the output. I just saw like the configuration of Comet. I saw the installation of Comet ML. It's running now the training job. This is going to take a second here depending on your computer. By the way, this is an M1 computer. It's not slow, but it's not fast. When I run it on my other computer, it's lightning fast. I have an M3 Max computer as well. When I run it there, it's just super, super fast. Okay, so this is done. Look, I get the train model succeeded at the end. So that's cool. Let's look at I'm going to click here, scrollable element, so I can get the full log. Look at this, everything that ran here. We should get both steps should be successful. So if I go up, here is the log of the job complete. Pre-processed data was successful. Then it goes into the second step, which is the train step. It does the entire installation. These are all of the environment variables that I have available. You can do a lot of debugging. You can understand how these jobs work just by looking at these logs. This is great. Look at this. These are the arguments that it's going to pass to my script. It's going to pass a batch size of 32. It's going to pass the epochs with 50. It's going to pass the model there. So all of that information is here. Look at the logs. Keras version 2.12, that's the version that I'm running here locally on my computer, 2.12. You can see all of the logs from the training process. Look at the accuracy, starts in 0.20, starts increasing accuracy. Boom, 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 0.89%, 0.90. It goes up and up and up and up and up for 50 epochs. Like validation accuracy ended up being 92%. and the training accuracy ended up being 95%. That's pretty good. Okay, so see, I printed out validation accuracy 0.92, and you get here all of the information of the experiment. That's pretty decent, and the job completed. Okay, so that is great. So this is what I'm going to do now. I'm going to go back to session 1, and I'm going to change local mode to false. I want to run this in the cloud. Remember, when you make a change, go to the line of the session that you want to run up to session 5. I mean, we're in session 4. So I'm going to go to this line, which is the final line of session 4, and execute every cell before this one here. So this is going to execute in order everything you want to make that. While that runs, I'm going to go back here. I'm going to go to Comet, and in Comet, you can see the training job that we just created. This training experiment is the one that we just created. Look at how much data we just logged here. Look at this. This is beautiful. All of this, you guys did not see me doing any of this. All of this was tracked automatically by Comet. You can see my accuracy as it was increasing, as I was training my model, the validation accuracy increasing. You can see the losses going down as they should be, the duration of every epoch, like how long it took every epoch to go through. Look at the confusion matrix. If I go to confusion matrix, this is my confusion matrix, which is great. There are 3 mistakes here, 1 mistake here. That was it. That was my confusion matrix for the validation data. Let me see, what else? Code. This is the code that we used to create those charts. I mean, my training code, my training script, that got locked. I can make changes now on my training code, but I will always keep a copy here together with the experiment. That is awesome. That is very important. I also locked the model. So if I go assets on artifacts, look, I have the model here. Look, penguins, see? These are the models that I logged, which is very important for me to have. I have the confusion matrices, I have the source code. I mean, you can just go here and check every single value of accuracy, batch accuracy, all of the values that we tracked, they are right here. Awesome. So let's go back to my code. This should be ready for me to execute my session. See this long output, it tells me that the session was created. And now I'm gonna go run the pipeline, and I'm gonna execute the cell, and that tells me that the pipeline is executing. If I go up to SageMaker here, and I go to the list of pipelines, you get session 4 right here. I'm gonna click on session 4, I'm gonna click on this one here, and you can see here how session 4 is executing. So it's starting by executing the pre-processed data, and when it finishes, it's going to execute the train model. So our pipeline now is not 1 step only, now it has 2 steps. I ran this before, and therefore I have some data to show you, so we don't have to wait for this pipeline to finish executing. But let me show you here, let me actually show you a previous execution. So you can see here, this is just a previous execution, and you can click on the, like we saw before, you can get all of the data by just clicking on every step and sort of like looking at all of the data there. I want to show you something else, which is the experiments that we generated. Unfortunately, SageMaker just created this new Studio interface, and the previous interface SageMaker is calling SageMaker Studio Classic, just made up that name. They have not ported the experiments from the classic version into the new Studio version, okay? So you have to enable Studio Classic in order to see experiments. Experiments were a piece of crap in SageMaker before, now they're even crappier. That tells me that a lot of people are not using experiments here. Anyway, if you go to experiments here, it's going to give you all of the information that you need, where you can learn how to use them, etc., notebooks, etc. But it also tells you that in order to see the experiments, you have to go to SageMaker Classic. You have to enable SageMaker Classic to see the experiments. I did that, so you don't have to. So there is a button here that says Studio Classic. So if you click there, you're going to get here the ability to enable to start Studio Classic. I did that. And when you open Studio Classic, you're going to get this. This is the previous SageMaker Studio. This is how it used to look like. And there is a section here that's called Experiments. And you can go to Experiments, and you can click on your pipeline. Let's go to Session 4 pipeline. And within the session 4, you can open the training job. And now you can see here the information that we tracked during our training job. Remember that we used the regular expression, so you can see the validation loss, the minimum value, the maximum value, the accuracy. It went from 0.17 to 0.96. I mean, you can see here everything that, charts with no value. I don't know why. It's just the output artifacts that we saved. So anything that you created during the experiment, SageMaker is going to track here. Again, unfortunately, the experiment tracking in SageMaker is not top-notch. My recommendation is just to use a separate tool like Comet. It's just much better. It does a lot of stuff automatically. You don't have to deal with this. Hopefully, SageMaker improves on this. But yeah. All right, so let me check here on the process. We're not going to wait for it. There's no point waiting for it. Still executing. Yeah, it's going to take, the pre-processed data takes like 5 minutes. The training job will take another, I don't know. Let me check here. How long is it going to take? But a training job, oops, sorry. I don't even know what I clicked. Training jobs. The training job should take about 3 minutes to finish. So let's just not worry about this. You can take my word for it. This is going to work. And then in the next session, we're going to do something that's super cool with the new version of Keras. So with that being said, I'll see you in the next session. Thank you, and see you soon.